Welcome to the session on building RAG-based generative AI applications using Vertex. My name is Eva Duerr, and I lead product team for cloud artificial intelligence in Google in California. And I'm excited to be joined by co-speakers later on, Alan, who will show you how to actually build generative AI applications with RAG, and then our honorable set of customers that will show how to make an impact with that technology. So where do we start? So I want to kick us off with why RAG and why is that important? And why are you all here, right? Why is this room so full despite the lunch? Maybe just as a warm-up questions, quick raise of hands. How many of you already experimented with generative AI applications? Wow. I would say 90 to 100%, I cannot see very well. How many of them, you put them into production? Yeah, that's the difficulty. I always say putting stuff into, or applications into production in generative AI, it's like climbing the mountain. The first 80% is pretty easy. You go through the valleys, you are in the shadow of a forest, and it's kind of easy. But that's when 80% you are there on top of the mountain, but it gets steeper, it gets rockier. To get to the 100%, you need that 20% extra. And this is very similar in putting AI applications, AI systems into production, because you and your employees take decisions based on that technology. And that's where RAG starts playing a role. It provides that opportunity for grounding. Within Google, we like to say that LLMs are linguistic calculators for words. They can probably do some math, but they don't do that based on the deterministic calculation. They do that based on probabilistic set of examples they have seen. So is that a reliable source? And to give you just an example of when LLM could make a mistake, despite the fact that in this example, it has the knowledge, it even has the user session data, still it outputs an inaccurate answer. It just doesn't know that there was a tool released already in 2022. So how do we fix this? And that's where RAG starts playing the role. It provides an opportunity for search, semantic, keyword search, to additionally to augment your data and your knowledge to provide the more correct answer. It provides an opportunity for answer generation with citation. So you, as a user or as an employee of your company, you can check, do I trust that knowledge or I don't trust that knowledge? So in that respect, RAG starts playing a role. But a few cautions as well. Is RAG always good? And many of the customers I have been working with, including ours that will be speaking later on today, we ask ourselves, is always RAG the right tool to choose? And I always say, it depends. Maybe prompt engineering is the better tool because the complexity of what you are trying to solve for is minimal. Or fine-tuning the full model is the option because you have access to training data and you need to adapt a model. But RAG is typically the one somewhere in the middle where it provides the right opportunity for you to have adaptability, to have the freshness of the data and be cost-effective. Today, for example, we released Gemini with 1 million tokens. Is that the most cost-effective way to use the model? Well, RAG proves to be almost 100% cheaper. So we need to think about this set of balances is the right what's the right tool for the right problem. But in general, RAG is something that has been implemented and has been proven to work for many of the use cases. And how it works in practice, I would like to invite Alan to stage.
Hey, y'all. I am going to try and do a live demo here in a second. First, my name's Alan, product manager, work with Ava for a little while on Vertex AI Search and several of other products for developer experience. That's what I'm trying to get towards, is a good developer experience. And she talked a little bit about why you might need a RAG. We're going to talk about how easy it is to get to one. Let's switch over to the demo real quick. And there we go. Okay, so this is a console application. I've got a couple of backups here in case it doesn't work. And picking a source, we got this thing zoomed in pretty far here, so I'm gonna have to scroll down. A lot of times customers are going to crawl websites. If you own a website or you own the domain, you can prove that we have a really good crawler. It handles single page applications or complicated front ends. I've got BigQuery for structured data if your data is already in there, or you can use it as a conduit from other data sources. We have cloud storage, which I'm going to use in this demo because it's really convenient for me, and a handful of other data connectors, many more that we can talk about, including an API where you can put your own data in. Let's take a look at the cloud storage bucket, and I have a set of fake company documents here for Symbol Bank. These are just sort of like generic onboarding documents. Notice that we have a couple of different file formats in here. This is just unstructured data. Now, oftentimes in production, I might use a JSON-L file to apply some metadata to these documents, add categorizations or even ACLs to individual documents, allowing you to then filter your search results later. But for this demo, I'm just going to click next. When we're parsing these documents, we have a digital parser. We also recently have launched a new OCR parser if you have images of text, or a layout parser if you have complicated documents. And we're going to talk a little bit more about some of the document processing updates in a future slide. This is actually pretty compelling because this is one of the hard parts of ingesting a bunch of different documents. If all your stuff is in Markdown, you might not need it. We also have a new chunk mode to allow you to sort of customize the chunks, and particularly ancestor headings in chunks to help the sections of documents have the context of the document structure so they can relate back, trying to help preserve the meaning of the documents. And then we just give it a name. There we go. Typing is hard. And we click create. Okay, so that's the first part of the journey, just linking your documents in. If you already have them collected in a bucket, it's that easy. Connecting to other data sources is not too much harder. And it's ready for us to create the search app. I am going to wait and show you a few more slides here, hoping that this indexes in time. If it does, we'll just go through with this one. Otherwise, we'll move to that backup data store. It's somewhere in the like 5 minutes to get set up, but then 5 minutes of indexing, and we'll just see how we do. Let's switch back to slides, and we'll keep going. Okay, sweet. Okay, so while we're waiting, I prepared a few slides on sort of my favorite under-the-hood features. It's actually pretty easy to make a RAG application these days. There's a bunch of toolkits and open source frameworks for it. There's a lot of different ways you can mix and match them. Literally dozens of frameworks and dozens of options for components makes an exponentially large space to go exploring. And I've built many of them. You're going to sort of pick across several of these things. There's a lot of different patterns, a lot of ways you can do it, but you're going to pick across most of these components. And document processing, we've already talked about. Chunking, how to organize the data that you have processed such that it retains its semantic meaning. Embedding it, basically asking a model to encode that semantic meaning into vectors so that you can then search across them. Storage, where do you write it down in an efficient way? Querying, there's actually a whole lot of query prep that you're going to end up doing if you start doing this yourself. spell checking and then like rewriting versions of the user's query to try and determine their actual intent. And then, of course, doing a search efficiently, quickly, and potentially at scale, depending on your use case. It's a lot. It's a lot to figure out. We kind of condensed it down to 2 chunks. And I did that first chunk in the first part of the demo. I'm going to do that second chunk in the second part of the demo. And within each of those chunks, the preparation chunk, getting all the data ingested and indexed, there's a lot of customizations that you can see on the right-hand side. So I already mentioned the bringing your own metadata. You can actually customize the schema and the synonyms that you might use to describe your data or your space, which is pretty important because that can manipulate the embeddings, and the embeddings is really where the semantic meaning of the documents are. We do have a bring your own embeddings. This actually works across all types of data, so it doesn't have to be text. If you have custom embeddings for different modalities of content, or for text or your own specific space, just bring those and we index those into our own search engine as well. Auto-tuning the search adapter, I'm pretty excited about that. That manipulates the embedding space for retrieval. Again, trying to tune it towards specific domains if the out-of-the-box embeddings model doesn't really understand your domain very well. And then some other features are certainly on the way. Bring your own document processors and chunking if R doesn't work for you, or bring your own ranking adapter at the bottom, or different search adapters. Pretty cool features when they come, but we'll keep going. This slide is in here really just to talk about if you're building RAG, most of the time you end up building search, right? You're effectively doing search. I've seen a lot of recent tweets talking about how frustrated developers are with RAG because they're investing all of their time building search as opposed to generative AI. So under the hood, search is a complex system. You're pretty much always going to need traditional keyword search, and now we're adding vector search or semantic search on top. You have to be able to bring all of those search across both paths back together, re-rank across them, filter, boost, do whatever you need to do, and then provide reasonable results and generated summary on top. There's just a lot going on here. I mentioned document processing. This has been a thing that we were pretty good at, and now we're actually really good at, and I'm pretty excited about it. It's kind of an unsung hero of search because it's really, really, really hard to do right. If all your stuff's in Markdown, don't worry about it. We'll just skip the slide for you. But if you have a bunch of documents that have embedded tables or figures and tables, and those figures need annotation, this is actually really, really important. And it's really hard to get right. If you look at how text is encoded in these documents, the meaning of the column of the text is not applied to the cell or the row of the text. Those are hard things to get right. Okay, I kept this slide in too because there's a part of document processing is annotation. So as we retrieve information out of the document, we're annotating those with attributes that we know about the entity in question. This is an example of Warren Buffett. We know a lot of things about Warren Buffett based on the Google Knowledge Graph. And we're doing queries against the Google Knowledge Graph and adding that to the annotations that we put into your document, as well as the questions that you're being asked at query time. Those annotations help derive second-order meanings, not just the word that you type in, but the meanings behind them. This slide I really like too because it talks about re-ranking model. It's kind of hard to see the white boxes on the background. I apologize about that. But in short, millions or billions of documents are going to end up in your index. We're going to do a scan that's really, really fast, but it's not super accurate. We're trading accuracy for speed here. And that's normal. That's how most vector databases work. But you end up with hundreds of results because of that. So you need to go through an L2 re-ranker or a re-ranking step afterwards. That re-ranking step is very accurate. And that gets you down to a handful of results. Think about using a Google search index, like a Google search engine. If I don't see it on the first page, I usually just research. I don't go down to the second page or third page, or et cetera. So the first page of results, effectively, for your search is going to be really important. And that's what we're doing with this L2 re-ranker. And so this is, I think, a pretty good visual of like, hey, lots of different types of data. They can come in from different sources. You can actually search across multiple of those sources at once. We call it blended search, or people are using it as internet search now. But it can bring multiple of those fast index scans together and apply that L2 re-ranker across them at the same time. So you can have multiple backends being searched efficiently and accurately just in one search. That's pretty cool. And then you get the same grounded answer. And then here we are with the different data connectors. We've launched several data connectors recently, just trying to make it easier to ingest data from different data sources. I demoed the cloud storage one and BigQuery and websites, but we've got a bunch of other native integrations to make it easier for you to ingest your data without data prep being a prerequisite to using the index. Okay, I think we're gonna go try it out. Are we back in the demo? I'm going to say no. I'm going to say no. Let's be cautious here and say that we are not ready, and I will use the backup one. Okay, so I'm going to, oh, I didn't talk about what I was doing. I came over here to apps, and I'm going to click the new app. Oh, you can't see it? Can we switch over to the demo real quick? There we go. Thank you very much. Cool. We were in the data stores before. I'm going to switch over to the apps and build a search app on top of that data store. And there's other types of apps in here that you can select. If you get a chance, you should play with the agent preview because it's pretty neat, adding layers on top of search efficacy. But let's just start with search for now. We have different types of search, and if you get a chance, go see the healthcare search because I'm very impressed with what they've been able to put together for that industry. But let's stick with just the generic for this example. I'm going to do the extractive answers within the Enterprise Edition. It's just a means of getting more data into the chunks. There's some other features that are also behind that, and if you use website search, you do want to keep this on. And then I'm going to show you with the LLM integrated into this pipeline. So that's kind of an add-on feature. You don't have to do this if you're doing just retrieval. I'll show you just retrieval and your own generation in a collab next. Okay, and so then we're going to say a next demo here or whatever. And then we're going to say symbol bank. And this helps the model understand the context a little bit. There's a lot more that you can add to it. And then you can select across different data sources that you have set up here. Notice that we have, ooh, the new one. Ooh, I don't want the new one because I don't trust it. I'm going to do the old one and see if that works better. Ooh, and I am so zoomed in here, I'm sorry. Let's see if that worked. Okay, and so it's very hard to see at this level of zoom. I'm going to zoom out a little bit. Sorry, people in the back. I can't see the screen. We can see our documents here in the index. We can see an activity log of the various types of ingesting. We can go through multiple import steps. We can change the processing config for later. I'm going to jump into the config section here. And there's this preview widget that we're going to use here in a second. And I just want to show you some of the configurations for it real quick. So we can get just a basic search. You can get a search with a generative answer if you've added that. There's a search with follow-up answers. We can customize which model we're using. It doesn't say it on this screen, which I am frustrated about, but these are actually fine-tuned versions of these models that are fine-tuned specifically for answer generation with the citations. It should mention that, but you could pick across these models. You can customize a few of the extra features, and let's just go ahead and try it out. And so this is a symbol bank. We're going to ask, do you have a dental plan? I don't know. Nope, nope, I picked the wrong data store. All right, at least you know it's real. That's what I'm supposed to say. We can go through that real quickly without the explanation and pick a different data store, and maybe it will work. B next, demo, symbol. All right, and then we tried that one. Let's try that one. All right, and then I didn't switch it to the Gemini Pro one, but we're going to say, how do you do payroll? Okay, cool. So that's just a demo of how it's supposed to work. I guess I was too quickly with the other one, even though I thought I picked the right one. Whatever, forgive me. We've got the search results here, a generative answer, citations. We can do a lot of other searches playing with it. We can play with these tools. I think that I'm going to switch to this other tab, and this is effectively the same thing in a collab. I just want to show you how easy it is to do this on your own if you didn't want to use the LLM add-on. I also think it does a pretty good job of explaining what's going on under the hood. So you can just copy and paste the data store name here, and there we go. Sorry that you're waiting for me to figure out how to use my computer. Oh, paste it in there, and we just rerun all the runtime. All right, cool. Okay, so this data store is getting me authenticated. It is doing a retrieval with the API just to do the search. And this is not doing the LLM summary, anything magic. It is really just a query. I've got a little configuration about what I'm trying to return, including like extractive segments or chunks, depending on the settings that I put in there. And it's just doing an HTTP post to the endpoint. I get the results back. And then I have a function here called make context. It's just looping over each of those documents and stuffing them into a big text block. That's all I'm doing. And then I take that text block and I make a prompt, and I'm using that as context. It's like, hey, answer the user's question, grounded with the stuff. You can add extra things to this prompt if you want to. You put in your question, you put in the context, and you get back an answer. The answer is any LLM model. I'm using Gemini, and I am, haha, yes, got an answer. So do the query, got the results, make the context out of the results, make a prompt, wrap around it, get an answer, print out the answer. And I can do it in iterative fashion here. You end up with a lot of context depending on your data source. But I just wanted to show you how easy it was to do it both ways. Okay, I think that is it for my part. If we want to switch back to the slides. Sweet. I'm going to hand it off to Jeff. You ready? Thanks.
All right. Yes, actually, give it up one more time for Alan. It takes courage to do those demos live. Very nice job. So real quick, just a quick introduction. I'm Jeff Stone. I have responsibility for our contact center products and solutions that drives our award-winning customer service. And as Ava mentioned earlier, here to share a little bit about how we're turning those cool capabilities that Alan shared for their product into outcomes for our customer experience operations. So first, a little background about Discover. If you know who we are, usually the first things people think about when they think about Discover are customer experience and our focus on customer service and 100% base US customer service, all those kinds of things, right? And what that really means is the focus on that leads us to being one of the most trusted brands in finance, and our customers are very loyal because of that. But it takes effort. It takes a lot of effort to continue to lead in that space. And how do we continue to stay ahead? And one of the ways we continue to stay ahead in experience is continuing to invest in making our agents the best agents in customer service and finance in the world. And one of the ways we do that is giving them the best tools and capabilities possible. So today, the use case I'm going to share with you where we're taking advantage of those capabilities that Alan mentioned is improving our agents' access to knowledge and policies and procedures. And so a little bit about yesterday. Yesterday, agents used to search with the intent of finding a document, right? So if they had a question, the customer was asking about power of attorney, the agent might type in power of attorney, or POA for short, and find a document. They would have to go into that document, scroll, look for the answer, hopefully find it, and then get back to the customer. And with these new capabilities and taking advantage of the RAG model and the generative AI summarization, our agents are actually moving away from searching with the intent of finding a document and moving to asking a question and getting an answer. And what I'm really excited to share is that through this capability, we've been able to reduce the time to answer down 70%. So they're able to find their answers much faster than they could if they actually had to manually go in and scroll, thousands upon, well, not here to scroll thousands. We have thousands of pages of documents. They have to go and scroll potentially dozens of pages to find the answer they're looking for. So let's talk a little bit about the journey and additional context on the outcomes as well. The first thing you probably draw your attention to is the chart. So when we started this, we had to say, hey, how do we know that we're doing it right, that we're getting the right answers, and that we're successful? And you can actually see in the first version, actually in the first couple versions, we had to create a manual test set. So we had to sit down with agents, we had to talk to our policy procedure experts, we had to create a curated list, a golden list of questions and answers labeled so that we could start to begin the research. And you can see our first couple versions were not great, right? 30% of the answers were fantastic, 42% were ambiguous, we're like, up to interpretation, maybe a little subjective, and 28% were really just not great. And over time, it got better and better. And some of that was taking advantage of the parameters and the capabilities, some of that was enhancing our documents, and some of that was preamble tuning, things like that. We eventually moved a little bit out of manual testing, and we created, in partnership with the team, a way to automatically test these things. So it used to take us more time to manually go through and look at all the questions and make sure they were right. We were able to automate that now so we could run this basically every day. We were able to make some changes to how many documents we're returning to actually improve the grounding and reduce the ambiguity, which is why you see ambiguity go away. And on the latest version we're at, we actually have 73% of the answers that are fantastic. But what about the other 27%? And I'm going to talk a little bit about this too on the next slide. We actually flipped our mindset a little bit. So when you started this journey, you're like, ooh, I need to get accuracy as high as possible. And that's kind of where we started. And eventually we said, we don't have to be perfect. We actually want to mitigate and minimize the times when we're wrong. And so we flipped our mindset to not always be right, but actually just don't be wrong. And so some examples of that, and actually Ava mentioned it, we don't really want it doing calculations in math. That's not what it's good for. And so instead of trying to do that, actually don't respond. It's actually okay to say I don't know. And instead just fall back to the previous document, because that's all they were doing before. They were searching for documents. And so we can take advantage of the RAG search to just show the context of the documents. And with high accuracy, 90% plus, we're getting the right document in the first link back. And so we can just fall back to that. And now 73% of the time, they're getting the answer immediately. 27% of the time, they actually have to go into the document. But that's still much better than it was before. So now a little bit more on agent and customer experience. So think about what it takes when I'm searching those documents. If I'm an agent, I'm on the phone with a customer. That could lead to silent time. That could lead to hold time. That could lead to transfer time. Worst case scenario, that could lead to an escalated conversation with our customer experience escalation group. And so that's frustrating. And now, instead of that silent time, that hold time, they're actually just saying, oh, I've got the answer to your question. It's right here, right? It builds confidence in our agents, a variety of tenures, whether it's new agents that just came off of training bay, whether it's agents that have been here for a long time. They're able to get better answers to the customers right away. And there's actually some improved ancillary benefits as well. So think about the data set we get. When agents are searching for documents, all of our data logs for their searches are like POA and power of attorney and CBB, cashback bonus. It doesn't really tell us much. When they're actually searching questions with the intent of an answer, we're able to take those questions and give that back to our training team and say, hey guys, here are the questions that we're getting. Maybe it's changing because of emerging events. Maybe it's just, maybe we're not training on it as well as we could. And so we can actually use that to further improve our agents' experience coming out of training as they're supporting our customers. And so what does that look like? The cool thing is this is fully embedded into our custom agent experience platform Action. And you can actually see on the right-hand side, sorry for the group in the back, they can literally just ask a question as they're supporting the customer. They can say, hey, when does a customer receive match rewards? The match amount will be on the account within 1 to 2 statement cycles. And so it just immediately gets them the answer. And again, that 70% is going from minutes to seconds, which is a significant improvement in experience for both the customer and the agent. So 3 takeaways that I would leave you guys with. First, the capabilities that Alan showed were super easy to use. So actually building this was simple. It takes time to tune and train and validate, but building was very simple. And it actually took us more time to maybe educate in our industry. So within the organization, we're a heavily regulated industry, and so educating our legal risk compliance folks on, hey, how this capability enables outcomes and protects us as well. That took more time than building. So start with that if you're in an industry like ours. Flip your mindset, talked about it earlier. You don't need to be 100% accurate. Just try not to be wrong, right? Try to understand and know. We know when we're not gonna have a great answer. If an agent literally just types POA, that's not much context. So like, don't respond. Just give them the document and let them search themselves. And then I'd say the last point is these capabilities empowered our product team. So like all of the tuning, training, validating, it wasn't an engineering task. That was actually a product task. And so giving our product leaders access to the capabilities to change the settings, change the preamble, look at the data set. They were very close to the use case. They have high acumen, they understand the problem statements. You know, they are able to effectively move that chart much faster than somebody who doesn't have a ton of context about the outcomes. So those are my takeaways. Again, appreciate the partnership with Alan and the team in the product area, but this is how we're creating outcomes for our customers and for our employees. So thank you. And I will invite Ram to the stage to share another customer story.
Do you have to hold? It's not moving. The middle button, right? Hmm? Yeah, yeah. Oh, that one. Ah, okay. Okay. Hi, everybody. I'm Ramanathan Lakshmikanthan, Senior Distinguished Engineer at Palo Alto Networks. Those of you who don't know me, you don't know me for sure, who don't know Palo Alto Networks, we are a cybersecurity company. We provide a suite of products which go all the way from endpoint protection to app protection to security operations, which are fully automated for the SOC analysts. Okay. So with the wide variety of products that we have, we do get a fair share of customer requests coming to our support teams, right? And they spend a lot of time, to what Jeff mentioned, looking through a lot of documents, trying to answer the questions to the best of their knowledge, right? So we wanted to build a system which would enable them, help them, so that the customer experience to reduce the time to resolving these cases get shorter and shorter, right? So we started, some of these predate enterprise search or Vector AI Search. So we started building a system which will take all of our documents. We go through chunking ingestion pipelines, which clean all of our documents. These documents are public documents. We have a lot of private documents which talk about how to troubleshoot different products and different levels of depths. And we also ingest a lot of our cases, the cases coming from other customers, or our bug data systems like Jira's and Confluence and other things, right? So we built an ingestion system which took all of this. They cleaned it cleaned everything, and then initially when we started the journey, the Vector AI Search was not there, so we started with the Gecko embedding approaches, right? So it could only take us so far, and finally, we were close to 50% at the accuracy levels. And when we switched to the AI Search, we almost got an immediate bump of almost 20%, right? Today, with all the other capabilities, with Gemini Pro and everything, our accuracy is north of 95%, right? And where our support agents are getting questions, they're searching through this, they're getting a response from the system, and they're saying it's helpful to solve the customer questions or troubleshooting tickets, right? On the right side, it's the inference flow, which is described here. Basically, once we ingest all of our documents, we add it to the AI Search data store as structured documents. And then with other metadata, and sometimes we also add links to public URLs so that we get the ranking signals coming from Google searches also influencing some of these responses, right? In the inference process, we take the question as is, which is typed by the support teams. Sometimes they just copy paste what is there in the support ticket, right? It has context, but it might have other unrelated information like greetings or contact information and things which is not needed, right? So it's kind of going to what Alan was describing. We are kind of building a search, right? So we rephrase the long form question into what is called as an enterprise search intent and the actual intent which is needed. The enterprise search intent is then passed to ES to respond with top K documents. Then we take the rephrased intent and the top K documents, and we pass it through a Gemini Pro as a summarizer and a relevance checker. And we probably take, let's say, 3 or 4 documents which are most relevant to this. Then with the summary generated from all the individual documents, the final state is we go to Gemini again to build a final answer, which is it could be a concatenation of multiple sources, which could be private documents, public documents, even trouble tickets, right? So this gives a better response, and the support agents are able to use this to triage further, sometimes even close the cases which are coming in, right? We also built an automated system which can evaluate the responses with some of the ground truth responses that we have built over time. So this automation has helped us to, whenever we ingest new documents, or whenever we upgrade our prompts, or we add, when we migrated from Bison to Gemini Pro, this evaluation system helped us through all of this journey, right? And as part of all of this as well, we get human feedback, which is the support agents give us, was it helpful to solve the case? Did it fully resolve the case? Were there links which could have been more relevant to this, which are not found? So we collect all of those metadata, which is then used for us to kind of fine-tune the systems. So what worked for us, and how did we, what are the next steps for us here? So initially when we started, we didn't have AI search, so we kind of tried to build it with vector stores and Gecko embeddings and stuff like that. A lot of permutations and combinations with Bison, with fine-tuned Bison, with Unicorn, and all of these variations, right? So a lot of effort was spent. Both it was helpful for us to learn as well as to build these systems to production-ready systems, right? I talked about almost a 20% uptick in our top 3 recall just by switching from Gecko to enterprise search. The other things which have helped us is the robust automated framework that I talked about. What could have been better is some of these other connectors that the team is building. If it was a little earlier, I think it'll be useful for us. Next steps is, in the previous stage, we saw a bunch of calls to Gemini Pro, which are adding a lot of latency to our pipelines, right? So we want to see if we can, by moving to the answer APIs, do we get a better latency when responding to the support agents. Then the few other things is moving to the different connectors that the team is building out. And that concludes it. Thank you.
Close us off with a couple of really important closing remarks. We started this session by saying building production-ready applications. That's the goal. And both Jeff and Ram talked about how it's difficult to get to the last 20%. And this is where we invest a lot, because you can see that you struggle as well. In fact, over 50% of our customers say they don't have the skills, they cannot keep up with the pace. The other scary data point is that almost 70% fear that the employees are bypassing the security guidelines of their companies. So this is scary. So at the core of what we want to empower you to do is to build enterprise-ready applications. Jeff talked about how do I influence legal, how do I create trust within my own organization, because building that was fast, but at the same time, how my stakeholders within my organization actually trust the system that I built. So this is where we want to empower you, and we have invested quite a bit. So I'm gonna give a couple of examples: data governance and privacy. Your data is your data. Whether this is training data, whether this is prompt data, whether it's model output, we don't use that data to train our models. We have invested as well a lot in VPCs, in encryption, in ACLs, and access tooling, and so on and so forth. And last but not least, everything we do within responsible AI and explainable AI within Google and our own technology, we want to give it to all of you as well. And we have safety filters that provide you the guidance on categories of maybe violent, crime, war, sexual harassment, output that the model might have. Content moderation APIs, we just launched this, and provides you additional options to really moderate the output of the model. Recitation checks, yet another example to what extent the model has actually copy-pasted some other source. So we give you those confidence scores as well. And last but not least, bias filters. We know all that we need to mitigate and the risks of biases, because the reputation of our companies is at risk. So if there is one thing I want to finish this session with, is that we want to empower you to build successful enterprise-ready applications, successful responsible AI, generative AI applications. Thank you very much for your attention, and we look forward to working with all of you.